See, most people forgot about the Rubik's Cube back in the 80s, so it had its heyday and then disappeared, but mathematicians remain obsessed with it.
I mean, people probably are aware that there is some maths involved in a Rubik's Cube.
The reason I got interested in the Rubik's Cube was I wanted to use it as a teaching tool. In my day job, I study something called group theory.
If you go to any kind of Wikipedia page about anything to do with group theory, there will be in the top corner a picture of a Rubik's Cube. And the reason for that is that it has got quite a nice example of a group associated with it. And the group is the number of different combinations that there are on the Rubik's Cube. It's all the different ways that you can scramble up a cube.
So, for example, if you had a square, right, and I turn it a quarter turn, you still get a square, don't you? Right, and even if I take a square and I flip it over, you still get a square, right? So it has that symmetry. Now, this is what I study. So I started to learn how the Rubik's Cube work because the mathematics is the same. So if I turn this here, the right-hand side, a quarter turn, yeah, I can do that. If I do it twice, you get a half turn. You do it 3 times, that's equal to a quarter turn in the opposite direction. And if you do it 4 times, you get back to where you started.
Hey Numberphile, my name is Lucas, and I'm a speed cuber. That was about 9.6 seconds, although we got a little bit lucky.
Other things do have permutations and symmetry, but there's just something nice and tactile, and you can grab it and you can see everything as it happens. So there are a lot of other things with symmetry, but nothing quite as tangible as a Rubik's Cube.
The mathematics of the Rubik's Cube is rock hard, but we'll try and do a few things about it. We'll talk about the combinations first of all. How many ways can you mix up the Rubik's Cube? Let's do that.
This is my Rubik's Cube solving attempt for Numberphile. Here goes.
I'm adequate at the Rubik's Cube, so I can solve it on average about 1.5 minutes. So on a good day, if you give me a mixed up Rubik's Cube, I can do it in 1 minute. I will almost always get it done in 2 minutes. Personally, my goal is to be able to, I like to be able to solve it while talking to other people. So it's my goal to be able to solve the Rubik's Cube while having a conversation. I can do that between 2 and 3 minutes, give or take.
You've set yourself up, now. You know what I'm going to do. Give it here. I'm going to mix it up.
Oh.
So imagine I can take these cubes off, these little sub-cubes here, these, what are they called? Cubelets, qubits. We can take those off and just arrange them all on the table. I'm going to put it back together again. I'm going to do the corners first, let's say. For the first corner, I'll have 8 choices of corner cubes. I'll have 8 corner cubes to put there. For the second corner, I'll have 7 corner cubes left. For the next one, I'll have 6 corner cubes left, then 5, then 4, then 3, then 2, then 1. Now you multiply that together, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's called 8 factorial, written with an 8 with an exclamation mark after it.
So I've mixed up this cube for Matt. He told me that he can solve it while talking, so I'm going to give it to him while I talk to him about the Rubik's Cube. And there you go.
Right, so I mean, me and my big mouth, I did admit that I can solve it while talking to someone else. So I believe, Brady, you're going to attempt to engage me in conversation.
We can do the edges in the same way. There are 12 edges. We're going to put the edges in. And there are 12 factorial ways to arrange the edges. So we've got 8 factorial and 12 factorial. Now for each corner, there are 3 ways to orientate it. So there are 3 colours there on each corner, and you can, if you have free choice, you can move them around. There are 3 ways to do that for each one. 3 choices for that, 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 and you times them. What I've done is that's 3 to the power 8. 3 times 3 times 3 times 3.
When you were mixing this up, there's a number of different ways you could have mixed this up before you give it to me when I start solving it. So there's only one arrangement of all these pieces which counts as a solved Rubik's Cube.
And now finally, let's look at the edges, and each one has 2 ways to arrange it. And so there's 2 ways and 2 ways and 2 ways and 2 ways, and you times them together. And because there's 12 edges altogether, there are 2 to the power 12.
3, 2, 1.
these two corners are where I want them, but these two are the wrong way around. And so I know if I do that, and then double twist, that will have swapped those two pieces.
This is the total number of ways if I could take the pieces off and then put them back on again. Now, how many ways is that altogether? It's a very large number. Shall we work it out? 3 to the power 5, well, 5.2 times 10 to the 20. It has 20 zeros after it. But this is not the right answer yet.
Matt, are you doing maths here, or are you just kind of like a monkey having learned something by rote?
A combination of the two. I've memorized, oh, that's it solved, by the way. I've memorized a lot of combinations of twists. That's pure rote. And then what I'm doing is I've just got to spot what I need to do and then do it at the same time. And so my method is very lazy. I'm spotting one bit I want to do at a time and doing it. The more advanced people will spot two different things they want to do at the same time and then do those together.
I love Numberphile, it's great. So, and I saw the post about you're making video Rubik's Cubes, so I'm just going to mess this up and then solve it.
Not all permutations are possible. I can't reach every combination by these twists. In fact, if I take one of those edges off and turn it around and then start twisting it, I get a whole new set of combinations that you won't usually get to on a Rubik's Cube. There's it's called an orbit, a whole new universe of combinations. So if I do that with one of the edges, you get this whole new set. If I do that with the corner, there are 3 ways to turn the corner. And again, for each one of those, you get a whole new universe of combinations. And finally, if I take 2 pieces, like 2 edges or 2 corners, if I took them off and swapped them over, you again get a whole new universe that you can't really reach on a standard Rubik's Cube. Now, because of these universes, there's 12 of these universes, 12 of these orbits. So I'm going to divide that number by 12. 4.3 times 10 to the 19. Some people call that 43 quintillion, but I don't like things like that. 4.3 times 10 to the 19. It's a massive number, though. It's a massive number of combinations.
If you want the exact number of different ways you can mix up a cube, it's 43 quintillion, 252 quadrillion, 3 trillion, 274 billion, 489,856,000 flat. A number of possible ways. And to get a sense of how big that number is, there's not enough raw material in the UK to make 43.25 billion cubes. So you couldn't make enough to put one in every single possible arrangement. In fact, there's not enough of the UK to make enough Rubik's Cubes to have one in every single arrangement. If you started just breaking off anything around you, so just grab anything and break it off into a 57mm cube, the exact size of a Rubik's Cube, and then if you painted those, all the different possible combinations, by the time you had made all 43.25 billion, you'd have a UK-shaped hole over 20 miles deep. It's a mind-numbing number of possible arrangements.
And there we go. Brady, this is your solved Rubik's Cube.
So this was a big craze in the 1980s. Big craze. In the 1880s, exactly 100 years earlier, there was a similar puzzle that was also a big craze. It was this. This is called the 15 puzzle. It's got the numbers 1 to 15, and it's like the Rubik's Cube, though. You move the pieces around. The Rubik's Cube is essentially a 3D version of this. Now, there was an American puzzle expert called Sam Lloyd who would sell this puzzle, but he would sell it very meanly. He would sell it with the 14 and the 15 swapped over. This was how he would sell it. And he would say, "Can you solve it?" And he'd offered a prize of $1,000 to anyone who could solve this puzzle. What he knew, though, was it was like the Rubik's Cube. If you take one of those pieces off and turn it around, you get a whole new universe. You can't get back to the solved Rubik's Cube if you do that. And that's what Sam Lloyd was doing. But that is essentially a simpler version of this craze 100 years later.
Can I just say, for the record, Matt actually wrote the number on the board there, but you did that without looking.
I did it without looking. Yeah.
Let the record show he did that without looking.
Just knowing it was on the board was enough for me.
I guess it comes in the official Rubik's packaging. And, you know, this is the original design that they had when they invented it in